My name is Vredevoort, as I've been introduced by Jaap already, being in the community very early on. My first article about Hyper-V, which wasn't even known as Hyper-V yet, was back in 2006. So that's a very long time ago, and then I predicted in 2007 that within 2 or 3 years you would wipe away VMware.
Yeah,
But that didn't happen, so my prediction skills are not all that perfect. But nevertheless, it's also very nice to see how many things have changed in the past few releases. And personally, I like what I see and what I hear about the next version of Hyper-V. Let me introduce myself. I've moved to another company recently. I've worked for a company for 23 years, and I moved to Innovative. I'm now a colleague of Jaap as well. He joined us recently, and we focus on Microsoft System Center, Hyper-V, data center type of product. I've been a cluster MVP since 2009, so this is the 3rd year. I can't promise you that I will be a cluster MVP next year because we might be moving to the cloud and data management MVP, which is a new group which contains all sorts of different MVP groups. I've helped Aiden with his book. I was a technical reviewer for the Mastering Hyper-V Deployment book, which I liked to do. So he actually suggested me to also write a book on the private cloud, because he required somebody who had knowledge about the fabric, the servers and the storage, etc. This is also going to be the topic of my presentation. It's about Hyper-V in Windows 8 and what it means in combination with storage. At the Build conference, there was a topic on the data center or on the server, and it showed us all the new technology and features which are in the new operating system. And I tweeted a couple of weeks ago, well, if I were to discuss everything about storage, I would probably need 3 days to do a workshop and explain all the possibilities of storage in Windows 8. So these are all the server type of technologies in the server, the network and the storage. If we look at storage only, there are quite a few subjects we could talk about, since we only have an hour, so I have to make choices. For that reason, I decided to pick a few of these features which are impressive to me, which I would like to try out, which I have tried out with trial and error, because it's still a developer's release. So I've actually tried to build my presentation around a demo instead of the other way around. So that's quite risky, because if the demo fails, the talk will fail as well. So, but nevertheless, I would like to show you something. And what I'm going to show is this. This will build up to a kind of staircase. So I start off with creating VHDXs in PowerShell to show you some of the management capabilities of Windows 8. I will then use Windows 8 file services. I will be creating a couple of disks here. Then use Windows 8 file services to show you some of the pooling and spaces capability. I will then be serving out iSCSI targets, because there is an inbox iSCSI software target server in the operating system, and I'm going to need those targets for my virtual guest cluster on my laptop. So I'm not using any external servers. Everything is running on my laptop, so I have no network connectivity issues. When I have the cluster, I'm going to build a scale-out file server role, because that's the one we need if we need scalable file servers to be used as the storage for our virtual machines. Of course, we need cluster shared volumes, so I will talk a little bit about cluster shared volumes 2, version 2, as the scale-out file server role requires cluster shared volumes. I will then deploy continuous available, not a drink, to show you the SME2 file share capability for Hyper-V. And finally, if everything succeeds, and that's the scary bit. I want to show you the live migration, live storage migration between two SMB shares, which can live on different clusters. So you could actually live migrate, storage live migrate a virtual machine, which is nice. These are the topics I will touch upon. I'm not saying I'm going to detail everything, but I want to illustrate the different features in Windows 8 storage which will use those kind of features. First of all, we have a new storage management interface, which is like an API which you can use to address storage. All the current applications in Windows which configure storage or view storage, they will use this new interface. That's one. And of course, vendors will be able to write their own applications on top of the storage management interface. On the left, you see the pools and spaces, which could effectively be just a bunch of disks, the JBods, as you probably know about. In the middle, you can use an intelligent array, any NetApp, HP, whatever. And on the right, just a more intelligent array, but not such a large enterprise array, probably with shared SAS or PCI RAID, etc. So these are the three opportunities. This one will be addressed by Microsoft, so you can create a pool. This one could use the SMIS, which is supported by default. So if you have an array which supports SMIS, you can create pools on this one as well. But you can address the storage via PowerShell or WMI. And if your storage vendor hasn't done any work on SMIS, which is still in the works, they are also able to write their own interface to use this storage management interface and enable all the capabilities of the Windows storage stack. That's interesting. Let's start with the new age VHDX. You've already heard from Aiden that it will be, or I think from Peter, that it will be 16 terabytes per VHDX. It's the new default VHDX format for Hyper-V. The good thing is that it uses large default block sizes. The default is 32 megabytes for fixed and dynamic VHDs. For differencing disks, they will be only but they nicely align with 1 MB boundaries, so that you won't have any misalignments if you still have that. Some arrays don't do that very well. Also, the physical and the logical block sector size will be the same. It makes it very performant. It's really fast. It's mountable. You can mount it to your operating system, to your file system. You can copy and create files on it. It's also resilient. Resiliency is because it uses a log file, log file. It's not used for transactional data. It's used for copy on write of metadata. Maybe you have heard of the new ResFS file system, which will be in Windows 8. This will also use the same type of resiliency. It's convertible, of course. You have to be able to convert it from VHD to VHDX and backwards. And most of all, it's scriptable using the storage management interface. If you install the Windows File Services role via the new Server Manager, you can see there are a couple of different role features, role services. This one is installed automatically, the file server, and you can optionally use any of the other ones. I will be using iSCSI target on the parent partition of my laptop, and I will be using the services for continuously available shares. I don't use that one really, but this one is important to be able to show you the scale-out file server functionality. So, start with pooling. file services, when you have installed the file services role, you automatically are able to create a pool from a bunch of physical disks. So it's more like an aggregation functionality. On top of that pool, you create one or more virtual disks, and those virtual disks, they behave like a physical disk, so you can use them for anything you would normally use a physical or a virtual disk for. On top of that, it will support thin provisioning. It will be resilient to failures, physical disks. That means that if you have an array of physical disks, it's not an array, there's just a bunch of disks, there's no RAID controller involved. The software will make sure that if a disk fails, you'll be able to recover from that. So you will be able we will have mirroring and other types of redundancy. In one of the blog posts, which was on the Windows Build site, they talked about this feature related to the workstation, like for the client, and as a replacement for the extender. But if you use the right hardware underneath, and I'll show you later what kind of possibilities you have, you'll also be able to use the functionality and the flexibility of pools and spaces. So don't think of it as only a low-end type of storage. It depends on the type of disks you use underneath, and then you won't use the JBoss, of course. The next thing I've selected was the iSCSI server, the target server. It's an optional component of file services, and it helps you to easily serve iSCSI disks. Maybe you've heard of WinTarget. Microsoft acquired WinTarget many years ago, and they later transferred that to a product called Storage Service, iSCSI Storage Server. And we now have it default in the operating system as a part of Windows 8. And in the interface on the right you can see what it looks like, and I will show it later. The iSCSI target supports clusters, it supports CSV, it supports PowerShell, of course, because everything using storage goes through this storage management interface. What kind of deployment options do we have for Hyper-V? We are used, of course, to using external storage arrays, and the question was earlier, why should we use file services as a storage deployment option? Well, we'll have to try, we'll have to find out in practice, so that's what we're doing currently, to try out all these new technologies and find out if they're good enough. I think it's very promising, so I don't think you just have to ignore it just because it's only file storage. Because file storage in Windows 8 with the new protocol SMB2 2.2 is really very impressive. So we have, as a deployment option, we have remote file servers, we have spaces I just talked about, and if you want to use more or better and trustworthy storage, you could use clustered PCI RAID. Another possibility would be shared SAS. Maybe some of you know the left hand or maybe the enclosures with shared SAS controllers. You can use those, so you have an intelligent piece of hardware underneath, but still be able to use this for Hyper-V. So there are several combinations. And of course you don't want to implement it like this, although you can. I've got it on my laptop, I've got a cluster on my laptop, but if my laptop fails, it's gone. So you probably want to cluster this and cluster that, and we'll later see a couple of deployment options. I'd like to stop here. As you see, we've gone up the stairs a little bit. We are in the middle now, and I'd like to show you a couple I'll demo some of the features I've talked about so far. Hopefully it's going to fit on my screen. really. Thema in scripts. I've lost my directory. Open folder location.
Hans, alleen nog Vredevoort, dan ben je...
Ja, dan ben je er ook meteen.
Oh ja, thanks. Thank you very much.
bij de document.
The path is really long, sorry about that. I should have done that so differently.
Nou, je zit er
Just
gewoon
a
in
second,
vol.
it's not going to work this way. Make it a little bit easier for myself. I also have to start. This looks like a PowerShell screen, but it isn't. It's just a command prompt. So I have to go to the directory PowerShell. That's it. All right. First of all, there are loads and loads of PowerShell commands. We'll have PowerShell commands in the box for Hyper-V. Currently, we'll have to download it from a website, and then you have to add the library, etc., and use it. But in box, we now have Hyper-V PowerShell commands. There are quite a few. I'm not going to talk about all these. I will use a few. But most of the things you will want to do with Hyper-V, you can do with this one. The same applies to storage. So I talked about the management API. This is the one which uses the storage API or the storage PowerShell commands. As you can see, there are quite a few commands there as well. Amongst others, scripts to create physical disks, partition them, which I will need later. And also for the iSCSI target server. So if you would like, you could create your servers through the PowerShell interface. And they actually work better, as Aidan told us, better than the GUI interfaces.
So this part is superseded?
It's still in box, it's still used, but it will now use the new storage management interface. Like I told, all the current disk utilities, like Disk Manager, they will be using that interface. Yeah? So this is an example of a command which gets all the VHD commands. So you just search for things which have to do with VHD in the module Hyper-V. And I will be using the new VHD capability. Here's one which will create a 40 gig VHD. And here we are. It creates a nice dynamic VHD. As you can see, you can also do a parent and differencing disk relationship, or parent and child differencing disk. That's the one I'm doing now. As you can see, I create a new VHD called VHDX called differencing one, and it's connected to the parent VHDX. And all you have to do is specify the path to your parent. The parent path is over here. If you want a list of those VHDs or look at the current VHD, you just use the get VHD command. You can mount that command, so it's now connected to my file system. And as you can see, I have a new VHD, number 3, and that's where it goes wrong, because I have number 2 in there in my script, so the next one will go wrong. So I'll do it manually. Initialize. Number 3. And now we have, I'll just take a look at it from the disk manager. I could go on and on and on to create all those other commands, or use the other commands to create a disk. But here it is. I can format it, can use it, etc. So this is the type of work you can do in your scripts to create VHDs. I also needed to create that script to create disks for my, let me see, what is it? It's just a little bit too much. I wanted one to create the VHDs for my pooling. Now these are the commands you can use to the commands I've shown you. The next one will be used for pools. That's this one. So if I just create a couple of VHDs, because what I want to simulate is a number of physical disks. I don't have any disks around me, so I need to create a couple of VHDXs. And those are the VHDXs I'm going to use in my pool. So if I use the command to is it gone? Yes, it's
No,
gone.
Still out.
Where is it?
Bottom right.
Oh yeah, thank you. So with just one command I can mount all the VHDs. No. I'll leave them there. What I'll do next is try and use these disks to create a pool. So in the new server manager you can go to file server, and hopefully I can see my disks. If not, I'm in bad luck. Yes, as you can see, I have 7 disks. They're called the primordial, so that means the disks are still unused, they're raw, and I want to use them in the pool. Again, I could do that in PowerShell, but it's not all too easy to develop, as you can see. So I create a new pool, a storage pool. I can give it a name. And as you can see, it uses Spaces and Pool version 1 on my server. And you can also see that, because it will show you the manufacturer and the model, that you will also be able to use storage arrays which write to this storage interface. So now I'm using just virtual disks. I could use just a bunch of disks, but I could also use NetApp storage if they were ready with their interface. I could use HP RAID disks in combination with the storage and pools. So I create a pool. I say, well, let's all use them, and it asked me if I wanted to use 1 or 2 low latency disks for extra journaling information. Now, I don't want that at the moment. I just want the capacity. Here we are. So we create a pool. I commit it, and it's actually preparing the disks, and it's doing all lots of magic underneath to make a structure which combines those, which aggregates all those disks. So now I have the pool ready, and we go to the next step, and the next step is to create a volume. So I create a volume on top of the pool, And we can also call those virtual volumes or virtual disks. So I call it VDisk1. And here we have the option to use different kinds of functionality for the virtual disk. One of them is to just have a simple layout and use like a RAID 0. The data is striped across all the disks, but there's no redundancy. We can use mirroring, and of course then you will lose some storage capacity, or use parity, which is a little bit more efficient. As you can see, we have, although I only have 70 gigabytes, it says I can spend 6 terabytes. So I can thinly provision, and I won't do that because it's going to take a little. So I just I create a smaller one, not a very small one. Well, in the light of what's coming with the new file system, when we're not talking about terabytes anymore, but petabytes, 100 terabytes will be probably small in the future. So you can laugh.
If you can get the disc. Discs, actually, because there's a shortage.
Yeah, I heard. So Aiden will not be able to test it yet.
It's only in Arnhem.
Yeah.
And if so far is taken, we don't need disk space anyhow. If so far passes Congress, then we don't need it anyhow.
No, we just stop using storage.
We do. The Americans don't.
We need to Hyper-V.
Okay, now I have to actually use the disk, so I go to, I can choose to do a drive letter. I just say, alright, I'm happy with it, and now it actually creates the disk, it creates the partition, it formats the volume, and there it is. So here we are. We have a 100 gig disk, but because I use, I think I used striping. I think I used striping, so we have effectively 65 gigs of storage. All right. So far we have the disks. Now we have to present a disk to the cluster. I have two nodes, cluster node 1 and 2. Now I have
one question.
Yeah.
In the case of failure, are you able to pop out these disks into another server and import those disks?
You mean all the disks, or just one disk?
No, it's like in a RAID 5, you take out 3 disks, put it in another server, and import those disks. Does it understand that? Does it understand?
Well, you can replace the disks and it will
rebuild.
Yeah.
But
if you take out one disk, you have nothing.
Number 3. Okay, let's say 3.
If you take 3, it depends on your striping capability.
No, Hans, I think he meant if you have a server failure, which is not related to disks.
Oh yeah, of course.
Place all the disks in a different server and will it take up all your
It's not something I've tried out, but of course you have to do this. I preferably do this in a cluster. Right. So if you're using pools and spaces, of course, if you're a very small shop and you don't have any money, you'll do this the cheap way. But if you want to use the flexibility of pools and spaces, but you need the high availability, you will also use file clustering to make also the underlying disks redundant. Okay. Yeah? So that goes for everything. So I have two storage VMs which are in an ordinary cluster, and I want to hand out a disk. I've already created 2 disks which are already connected to the server. But let's just create another one to show you the new interface. And I can say, well, I see that I have the H disk. I'd like to create a virtual disk on that one. And here we are. I've already created the target for the cluster, storage cluster. and we commit it, and now the disk is presented to my storage cluster. Very easy, and as you can see in the interface here, I will have a couple of two initiators connected to that disk, and they are also already connected to the current disk. So now, because after a refresh of the disk, it will also show up in the cluster. After I have formatted it, of course. So if I just connect to my cluster, I have storage node 1. You see if the cluster fails and manage it here. Here we are. I have two nodes. You can see a little bit of the user interface of clustering in Windows 8. One major change is here. What we used to call applications and services is now called roles. So here we have a role. We have the cluster nodes which can have priority. So I could say, hey, let's assign a low priority or a high priority, meaning that some of the services or virtual machines, if this would be a Hyper-V cluster, I could say those virtual machines would have to start first before the other ones. And I already have storage, and the storage I connected earlier was translated to cluster shared volumes. So if I just go back to the disks, no, I'm in the wrong place. I have to take a look at the disk manager, which is still there. Again, using the new interface. I online the disk. Of course, this could be done with PowerShell a lot faster. Let's try. Here we are. And node 2 might need a refresh of the disk, just to be able to see it. Otherwise you cannot add the disk to the cluster. Sorry?
Nee, gaat goed.
So here's the disk, I have to online it. It doesn't typically developer issues. So if I would now add a disk, it probably won't see it. It does. Okay, I'm lucky. This is so risky. You know. So many things which can go wrong, which have gone wrong, and I had to rebuild it and make copies. And it was very exciting to learn, but also very frustrating when all the things went wrong. So I'm really looking forward to the beta, which is coming next month. So I have the disk, and as you can see, you can now just you don't have the question, are you sure you want to use cluster shared volumes, and you please accept that you only use it for Hyper-V. No, it's out of the box. There's no separate folder for shared volumes. It just has storage, and as you can see, the new disk is in available storage, and I can just say add it to the cluster shared volumes and ready. So now I have a third volume if I'm correct.
Would that mean that cluster shared volume is more supported for different services as well, like SQL?
Yes, they're still looking into a different functionality for, or different use cases for cluster shared volumes. It will be used for file services, because that's what we see here. Although it's not guaranteed, they can withdraw it in the final version. SQL Server might use it, that's not defined yet, as far as I know. But they're also asking us what other use cases would there be for cluster shared volumes. So it's not really, it's not a restriction for Hyper-V anymore, which is good. So if I look at my cluster shared volumes directory, you can see I have the third disk now ready, and you can also see the size. One major difference is that a cluster shared volume is now a normal mounted drive. It's in a mounted file system. So it doesn't have the other, I can never remind the name of that.
Of
Mount
that.
point.
No, it's not a mount point. It is a mount point now. I think it was a repass point or something like that. Junction. It was a junction. Correct. Thanks. And many management products couldn't see the set volume, so you'd never know if you would run out of storage. And in this case, it's just an ordinary disk, and just easier to manage. All right, we have a cluster, we have storage, and these are the ingredients for the next part of my presentation, which is the scale-out file server role. No. Hello, where are we? Scale-out file server role, here we are. This is an interesting one. I think most of us know the current file server. It is able to fail over from one server to the other, but it has its own disks, and the disks have to fail over, the shares have to fail over, it takes some time, it's slow, although many file servers or applications are capable of handling the failover. But also, you can only have, if you install one virtual file server in a cluster, you have an IP address, you have everything related to that file server, a separate name. If you want to have active, you need two file servers and they have to cross fail over to each other. So it's not the ideal one for storing a virtual machine on, especially when it would go down. If you fail over, you lose connectivity, and if a VM loses connectivity with its storage, it's gone. So this is not really useful, although in the past I know some companies who used just ordinary file shares to store a virtual machine on. Maybe some of you have tried that, and you can do it if you set the right permissions. But you have no availability. The scale-out file server role is a new role which actually distributes the network name across the cluster. So if you have 4 nodes, every cluster node will be aware of the name without failover. It's just aware via the SMB2 protocol. It's a cluster resource, so it can fail over, but it doesn't have disk resources. It only uses the CSV which was already underneath. As I show you, I already have 3 CSV disks online, but you don't have to configure those for your scale-out file server. The scale-out file server is just a name and an IP address. No, not even an IP address, just a name.
Does that use DFS?
No, it doesn't. It doesn't. But you can combine it. You can. It will, if you go to the share, it will actually use the IP address of the node itself. That's how it works. The shares are also online on all nodes at the same time. That's good for Hyper-V, of course. And it doesn't matter where the role, the scale-out file server role is running. It can be anywhere in the cluster. Also, the moving of the role, the scale-out file server role, doesn't involve any downtime. The shares just stay online.
So basically, it's several VMs connecting to the same disk.
Yes, they can because the VMs are on the CSV, and they're physically on the CSV.
Yeah, but they're storage disks, so where the actual data resides.
Yeah.
It's all the same disk.
Yes, it's the same, and the file share is of course the location, the access point where the VM will be created. It requires Windows failover cluster server to start with, so you have to meet the failover cluster test. It requires both file server, the server and the client to be Windows 8. And it also requires the file services, including the services for continuously available shares. Trick again. So that's the one I showed you earlier on the screen, the extra checkbox for the shares. And of course you need the failover server cluster feature.
Hans?
Yeah.
The client here, is that the Hyper-V server in this case? Is
Yes.
that both server and client?
Yes, well, my storage cluster is my file server cluster, and normally you would have, well, I think I'm going to show you that in a minute. It's not in this slide yet, but I'll show you in the next slide. that the Hyper-V cluster and the file server cluster can be separate entities, but it can also be one and the same. It's nice. So the deployment options for Hyper-V are using just the ordinary storage array, but you will be able to use new functionality with many of the storage array vendors. You probably know the VMware technology VAI to let the controller do most of the copy work. It will also this technique will also be available in Windows 8, and actually anything which uses the copy command will automatically use ODX, which stands for offloaded data transfer. So if the array supports it, even a file copy, an X copy, or whatever will use that capability. You can use file servers, of course. We talked about that. We'll show you that in a minute how we can use that. We can use clustered PCI because we don't want to lose the physical disks if they're not physical RAID. So here are a couple of examples. So the left one we've seen, this is the one we know very well, although not yet for a file server. This is the one with shared SAS. So in this case we will have a clustered space, and that's the one you were referring to, because I said you need to cluster your underlying storage to make it reliable. And this could be just a shared JBoss SAS. In this case, we have. This is the difference is here that this is equipment which will probably arrive in the coming month or year. Cluster PCI RAID, which will also be able to talk to or use the shared JBoss. Offloaded data transfer looks like this. Normally, when you copy a large file from a client to a server, or between servers even, it will create a lot of traffic and will take a long time. With ODX, offloaded data transfer, we will use a token, and that token just is a point in time saying what is the state of the copy process, which actually happens over here. So it's not the servers which are doing the work and doing a lot of connectivity and copying. It's the token which just tells you where you are, but the actual data transfer is between the storage array controllers. This could be a copy on the same array, it could be a copy between two arrays, it could be a copy between locations, with the same using of the intelligent array capabilities. This is the one for Jetsen. Although we are not sure, I have to say this, that the right one will be able to be implemented or will be supported, but there's no reason why you have to use two separate clusters. Maybe it's better because you can separate your Hyper-V cluster from your storage like you do now, because now you have a storage array which also uses redundancy and the separate networks, etc. In this case, you have Hyper-V servers over here, and two of them are connected to storage. It can be pools and spaces, it can be a storage array, blocks storage, but it's served out as file storage. So on the back end you have block storage, and on the front end you have a file server. To talk a little bit more about cluster shared volumes, although it's only cosmetic, cluster shared volumes will show up as CSV-FS. But CSV-FS is of course no file system, it's just a renaming of the resource type. There will be a new file system, which there was a blog on only a few days ago, called ResFS. Unfortunately, I haven't had the time to create any slides on that one, but that will be an entirely different, entirely new, rewritten file system, which can grow to how much, 4 petabytes, and have really large files, and is very resilient. That's what the name is for. But this is just CSV-FS. It's for Hyper-V and other roles, as we said, so we can use it for more purposes. I showed you it is very easy to add a disk to cluster shared volumes. it is high scalability. There are a lot of improvements to improve the reliability, and we really need that, especially with redirected access. Redirected access is not gone, but it is better supported, and we'll be able to use the new networking features of Windows 8, like multi-channel and teaming, etc. But Microsoft has done a lot of work, especially for backup operations, where you don't have indirect I/O for backup anymore, or at least it doesn't matter anymore. It also has a lot, much better interoperability with file system mini drivers. So if you had a vendor with antivirus or a replication software which was trying to replicate files on the CSV, you would run into a lot of problems. Also with backup we had lots of problems in combination with CSV. And they have rewritten it and created a new technology, I think it is proxy, CSV proxy service, which will allow those filter drivers to get what they need. And that's effectively the CSV filter driver, which sits on top of NTLS, more or less always took preference. We have very deep integration with all the storage and network technologies. So all the commands I showed you, they are also, you can use them with cluster shared volumes. And the very important one for reliability is that you don't need external authentication. So now you're dependent on a domain controller for CSV, and that will be gone. We have direct I/O for more scenarios, so that's good for the backup scenario. And if you have multi-site clusters, you will be able to use multi-subnet, which is not possible today. I told you that there is still some sort of I/O redirection, but it's much faster. It's really fast to use. And it can use as you show here, the the SMB, what's it called? Multi-channel capabilities. In this case, you don't have to team. You didn't talk about that one, multi-channel. But if you take two 10 gig adapters here, SMB2 will be able to aggregate or use both channels at the same time. You have both load balancing and you have redundancy at the same time. And if you have to do I/O redirection across this network, when this one fails, when the connection to the disk fails, of course you will have much faster redirection possibilities. So it's really high speed CSV I/O redirection.
So is that an automated process? For example, when you link to the node is down and you're in redirected access mode, does it automatically choose a different network path to include?
Well, I'm talking about this. If this goes down, if this network goes down, then it will go over the other networks. And in that case, you just have extra redundancy here for your redirected I/O.
Even though that's one of those two is not a designated CSV network.
Well, there isn't really a designation for a CSV network. It's CSV takes networks with lowest metrics.
Yeah, it uses network metrics. Yeah. So if you want to make sure that you're going over this network and not over this network, you have to use currently it's a PowerShell command to set the metric of the network. Lowest metric is for CSV, but the lowest metric is for live migration. Yeah. And it also default chooses the networks which don't have a default gateway. If every network has a default gateway, you have to be careful and set it yourself. In this case, you see that this one doesn't have a connection, so the I/O has to happen. It will take, well, as I told you, not only it doesn't only use the SMB multi-channel, it also uses the RDMA Aidan talked about. So really high-speed networking. This seems like a rather big configuration, which could be very expensive. I'm not sure if you're going to build this one in your labs, with InfiniBand, etc.
No.
No?
don't have disks.
As you can see, we have a Hyper-V cluster on the top. It has both an Ethernet and an InfiniBand NIC. because InfiniBand is also a supported interconnect for your servers. In this case you have both the 10 gig and the InfiniBand, and on the bottom you can have any type of storage, and in this case it's a redundant array. Yeah? For the demo I'm going to do now, I will be using my laptop. It is a Hyper-V server or Hyper-V Windows 8 server. It has the iSCSI target installed and the file server role, because I can only present the disks via the file server and the iSCSI target software. I have 3 VMs as I showed you, and I've enabled the file server plus the continuously available shares. And I have a few clustered virtual disks. So here we are at the top, and I'm going to show you, if everything works right, to show you storage migration of a virtual machine between VM shares.
That works really fast.
Sorry?
That works really fast.
You will see it, if it works.
If it works.
Probably also finish really fast.
Probably will.
Even faster.
Thank you.
That's the advantage of having SSDs. Go faster.
Let me see. I want to create a new share. Now, I'm first going to show you the cluster to give you an idea of what happens over there. Here's the cluster. If you want to create a scalable file server, you configure a role. I've already got one running, but you can actually create multiple scale-out file servers. I'm not sure whether that is something you should do, but again, you don't have the best practices yet for that. So what we are going to do is create a new file server first. Actually, the continuous available part is part of the file server. It has to think a little. If you haven't got the feature on your servers, you won't be able to use the scale-out file server, so be careful to select that one. This always takes a little time because it's trying to figure out what the cluster, what kind of resources it has. So I'm ready, I can start it, and here you have the choice between the file server general use, which can of course be used still, but this is the one we really need, the file server for scale-out application data. It supports SMB protocol, it does not support NFS, and you cannot use role services like FSRM and DFS replication with it. Not with the scale-out file server. You asked about the DFS. This is talking about DFS-R, so I'm not sure if DFS...
It comes down to the type of files that you're putting onto the share. That's the important thing.
Okay.
So this is for big files that are kept open all the time.
It's for like Hyper-V virtual machines.
Hyper-V, SQL Server.
Okay, I have a file server called FS1, so I'll call another one too. It validates my cluster settings. And while it's creating, I can move over to the other one. Another one. I have to wait. So the file server 1 I've just created, as you can see, it doesn't have an IP address, only a subnet. I can finish it, and here I have it failed, so I cannot do two at the same time. That's what we know now. This is the one I was talking about. I can actually move that role by selecting the role and move it to the best possible, or just select a node, and I move it to node 2. And as you can see, it moves really rapidly. You hardly notice it. I can move it back, move to best possible, or select 1. So here we are. So if everything is correct, I should be able to go to the file shares. I have 2 file shares. VM share 1 and 2. And on this share is a VM. Not sure if there's any date on this one, no. So I have to look on the other one. This one has got, well, this one is really small, so that's not really fair. This is a bigger one. It will of course take a little bit longer because it has to copy the 9 gig of files to the other file share. But if you're using a new technology in networking, as we've talked about, like or in InfiniBand or multiple 10 gig channels, you'll be able to really rapidly, coming back to your question, how fast can you copy those virtual machines across shares? That of course depends on your network infrastructure. Okay, I have to remember that the VM is on that node. So what do I have to do now? I just go back to my Hyper-V server. This is my node, and I want to create a virtual machine on that share. Let me see. If you create a share, and I think I have one, I cannot create this one, but I can show you. This, you first create a folder, or you create first a folder to put the shares on, then you set the permissions on the folder to create. Oh, I've got one over here, I can do this one. This is something you have to do not on the Hyper-V server because the storage is presented to the file server. So I first have to go to my file server. This may be a little bit difficult to follow what I'm doing now, but what I'm doing is actually creating the folder. Let's take this one. You'll be able to download these scripts from our blog later. Let me see. I paste the command, it doesn't work. There we go. Okay, the directory is available. If I would create a virtual machine now, and I don't have the time to show you how it fails, if I were to create a virtual machine on that share, it will say, well, you don't have enough permissions. So what we have to do is we have to use the iCackles command to give permissions to the administrator, to the cluster nodes, and the Hyper-V server. So that's what you have to do. And they all worked. That's nice. So here you see that all iCackles are processed. The next thing is to create a new share. And that share will be share 3. I have to copy everything, of course. This has to be PowerShell, yes, thanks.
Power. Freudian slip.
It's recorded, you can cut it out if you like. Here we are, here's the share. The share, I gave it a scope. I can go over the command a little bit. What I do is I create a new share of type continuous availability is true. So it's I use the capability of the scalar file server. It has to be on this cluster shared volumes. I give it a name, I give it a scope, and the scope is the file server. Here you give the access to the share. So I give access to the files to the administrator, the cluster nodes, and the Hyper-V server. So now we have that, we can create a virtual machine, and then we have to go back to the Hyper-V server, of course. So I go back to this one, and I go back and forth a little, so try and hopefully you understand what I'm doing. Let me go to the scripts. Again. I've done the permissions. I'm now going to create a virtual machine. Which one shall I take? The 4th, because I already have a couple of virtual machines. I go to the command, I will open this one to show you what is happening. And try this one. Paste it. creates a virtual hard disk on the location I wanted it, because it has to be, I think it's on the wrong share. No, it's on share 2, but for the demo it doesn't matter. Normally yes, it's no problem because the share exists. So the next thing is to create a virtual machine based on with PowerShell. Here we are. And this is really a simple syntax. And what you're doing is this: you say new virtual machine, give it a name, give it a path. In this case, it's a file share, and it's the VHD path is the file share. And what else do you have to say?
Memory.
Oh yes, the path. This is the path of the configuration file, and this is the path of the VHD. And you give it a size or any other. If you want to use dynamic memory or whatever. If you want to add an HDA, for instance, you just create it over here. So the VM is ready. I have to start it, and it's succeeded. So that's good. This demo works. That's good. And as you can see, the VHD is on the file share. Okay. So all the ingredients are now available. I have a file server. I have an iSCSI server. I have a cluster. I have storage, I have cluster shared volumes, and now I want to move one of those virtual machines. I will take the big one to show you what happens. It's on an SSD, so it's not all that slow. And I would like you to recognize that although I'm moving a VM between two shares, those two shares could live on different file servers. Those could be different clusters. So you can live storage migrate a virtual machine from one cluster to the other. And this is ideal. This is one of the things we are really missing, which you do have in VMware. You can live storage migrate. Although you cannot, I believe you cannot storage migrate live between clusters. Can you? Does anybody know if you can do that?
Right now?
Currently?
No.
No. We will be able to do that with Hyper-V in Windows 8. So let's move the machine. And as Aidan told us that, I'm not sure if you told it.
I think it's possible to do live storage migration with two clusters.
In VMware?
Yeah.
Okay.
Yeah.
I'm not sure either because I don't know too much about VMware. What is different, at least, is that we don't need shared storage. We can use a local disk and move a virtual machine while it's running to a shared disk. We can move it to a share. We can move it from our USB disk to a Hyper-V server to shared storage. So if I would first just look at where is that virtual machine living? I don't have the virtual machine. That is, I can try the. No, this is not living on the
Just
share.
do that one.
I just take this one. It will be really fast, of course. Here you have the move command. It's not live migrate. It's not storage migrate. It's move. So the live migrate and the storage migrate command have merged. Here's the wizard. Now this is what I can do. I can move the virtual machine from local storage to shared storage. But then the virtual machine must be on an SMB share. I want to do this one. I can also move it to another Hyper-V server. Now I want to do this one. I also have the opportunity to say which parts of the VM are moved to which other parts. So I can actually say, well, some of the files have to be on different locations. I want to move it to a single location. That's easier for me. I can browse to the file server 1. And let's move it to VM
3 you created.
Yeah, but it's too small. So it's only one. So I'll move it over here. And you have to remember that if you do that, you have to write. You have to do the name of the folder. Otherwise, it is stored in the root, of course. So here we are. All the things are ready. We're moving the VM from share 1 or to share 1. And there it is. I should have shown you that the network adapter, the VHDX is now on share 1, hence 4, and I want to move it back to another share. Let's use the same choices again to a single location. 1, go to share 2, and this one is now empty. You see, it hasn't got any files in it. So I select this folder, I select next, finish. And it should now be on VM share 2. Now, is this cool? This will give you flexibility.
Hans, please skip the questions because we are running out of time.
All right.
The questions can be
At the end.
At the end.
Okay. Fine. I'll show you my last slide, which is the one I'm over here. So this is what we've done. We built up there are a lot of steps, but if you've prepared it, it can be done really quickly. And if you have it online, it's just a snap. So I thank you for attending my presentation. I'd like to deliver the point that you can really build continuously available platforms that shine for Hyper-V across a wide range of storage options. Thank you very much.